Good morning, everybody. Let's talk a little bit about drawing atoms today. To do this, we have to remember a couple of the vocab words that we've been learning in class. Two of them in particular jump out as very, very big ones. Atomic number, which is the number of protons, which can also be written as P+. Okay, and the second one is atomic mass, which is the number of protons and neutrons added. And neutrons can be N, as N0, abbreviated. Alright, trying to remember these things the way that I usually do it. Mass is a weight. Protons and neutrons have weight. Okay, electrons are too small to have weight, so we don't count them as having weight. So atomic mass is protons plus neutrons. They're the things that have mass. Atomic number is just the number of protons. Alright, so I'll pull up a periodic table here, and we'll look and see where we can find the atomic number. And it is always written right here at the top. Okay, so the atomic number of silicon is 14, which means that silicon always has 14 protons. Okay, it doesn't matter where you are in the universe, it will always have 14 protons. Molybdenum will always have 42. Lead will always have 82. Uranium will always have 92. I don't know why I'm finding all the 2's today. Okay, but that is key. That is how we distinguish what type of atom is what by how many protons it is. The proton is king. Okay, so when we start writing this, we will say the proton's number. Let's say that we have a proton with 16, or an atom with 16 protons. Okay, well, we look on our periodic table, we find 16, we say, oh, that's sulfur. It's always sulfur. Okay, so we can write down S for sulfur. We know that that's true. Well, we do some more research into this, and we find that this sulfur atom has 18 neutrons. Okay, so we're going to add those two together. It's like we said back here, the definition is the protons and the neutrons. So we add those two together, and we get that we have 34, a mass of 34. When we write this, we can write this on our symbol too. We write it on the left-hand side up above. So this means that I have a sulfur atom with a mass of 34. Okay, and the mass is the number of protons and neutrons. We know that it has 16 protons because it is sulfur, so we can subtract that to get back to our 18 neutrons. We keep on studying this, and we find that our electrons also number 18. Okay, well, we know that the positively charged substances in the universe like to find the negatively charged substances in the universe. So it stands to reason to think that if I have 16 protons, the universe would love it if I had 16 electrons. But unfortunately, everything doesn't work out that way. We don't have this, we have that. Okay, which means I have 2 extra negative charges on my sulfur. So I'm going to write that as well, and I'm going to write that 2 negative. And you can put negative too, it doesn't matter. I'll probably usually put it this way. But you'll have, so this tells me all of this information. Sulfur is 16 protons. Okay, it has a mass of 34, which means I have to have 18. It has a charge of -2, which means I have to have 18 electrons. Okay, so let's go ahead and draw this now. If we were going to draw this whole atom, we're going to start out with our nucleus. I'm going to put a little boundary around my nucleus. And we said that we have 16 protons in my nucleus. This is where colors come in, and it's very easy to see if you have colored. Colored pencils are very nice. So we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 protons. Okay, the neutrons are also in the nucleus. I have 18 of them. So let's go ahead and put in my 18, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 neutrons that are also in the nucleus. Okay, the electrons are a little bit more tricky. We've got to go back to our periodic table to figure those out. Now, firstly, the periodic table is organized according to atomic number. We have 1, 2, 3, 4, 5, 6, 7, right? The more protons it has, the more it goes down on the periodic table. Second way that the periodic table is organized is it tells us how the electrons are organized in an atom. So what we're going to do is we're going to look at the periods, which are the rows. So here's period number 1. Here's period number 2. There's a morning bell for you. Here is period number 3. Here is period number 4. Okay. If we look back here at period number 1, we see that we have 2 atoms, which means that in our atom we are going to have 2 electrons. Okay, so the number of atoms on that row tells you how many electrons go in. It's called an orbital, and I'll show you what I mean by orbital here in just a second. But my first orbital is going to have 2 electrons in it. My second orbital is going to have 1, 2, 3, 4, 5, 6, 7, 8 electrons in it. My third is also going to have 8. My fourth is going to have 18. Okay, so let's go back and look at this. We're going to... They're ringing the bell all over the place this morning. We're going to put those on there. So here is my first orbital. Okay, and the electrons spin around the atom, or the nucleus of the atom. So we're going to put these in orbitals, just like a solar system, a mini solar system around my atom. Our first orbital has 2 electrons in it. So I go 1 electron, 2 electrons, and it's full. No more electrons fit in that. Okay, actually let's do a different color. Okay. My next one has 8 electrons, so I can put 1, oops, sorry, wrong spot. 1, 2, 3, 4, 5, 6, 7, 8 electrons in that orbital. And then it's full. I can't put any more there. Okay, now I am up to 2 and 8, so I have 10 electrons. I need 18, so I keep going. My next one has another 8. So 1, 2, 3, 4, 5, 6, 7, 8. So there's another 8. So that's 18 electrons. That's just what I needed. And so this atom is drawn. This is what sulfur, when we draw it out, looks like. Hopefully that was helpful, and we'll see you next time.